Let us look at the next section, students. This section contains 2 paragraphs. Each paragraph has 3 questions. Each question has 4 options, out of which only one single option is correct. Okay. So for question number 26, 27 and 28, we have been given. Consider the given reaction sequence. So we have a compound A, which is a clear solution. It reacts with HgNO3 whole twice to form a precipitate. The precipitate reacts with excess of Ki to form a soluble complex C. We are also given that the compound A, when it reacts with reagent X, it forms D. While when the D is boiled with H2O, we have an orange precipitate. So if we look at the questions which are given to us, in the question number 26, the examiner seems to be interested in the shape of the complex INC. Okay. If you look at the next question, the question number 27, it says, what is the molecular formula of the black precipitate D? And if you look at the last question asked from this paragraph, we have the orange PPT E is due to. Okay. So students, we might feel that there is not sufficient information to solve this paragraph. But if you look at question number 27, so question number 27 gives it all away. So it says, what is the molecular formula of black PPT D? So if you look at the compounds which are present, students, so out of these given compounds, if we try and figure out the color, so we have CuS as black, we have PbI2 as yellow, we have BiI3 as black again, and we have Sb2S3 as orange or orange red color. So option B and option D are directly eliminated. And if you look at CuS and BiI3, so it is further given to us that the black PPT, which is boiled with H2O, it gives us orange PPT. So students, this has to be bismuth. So BiI3, when it is boiled in presence of H2O, it gives us BiOI, which is orange in color. Copper does not give such orange colored compound. So the option A is also eliminated, and BiI3 has to be marked as the correct answer for question number 27. So we have figured out that the black PPT is of BiI3 and the orange PPT is of BiOI. Okay. So if you look at question number 28 now, the examiner seemed to be interested in the orange PPT E again. So as we had seen before, the orange PPT E is due to BiOI. So for question number 28, the correct answer is option D. For question number 27, we had seen before that the correct answer is option C. And if you now look at the question number 26, what is the shape of the complex INC? So now students, if we talk about the clear solution A, so it has to contain iodide ion, and iodide ion, when they react with HgNO3 whole twice, it forms HgI2. So this HgI2, it dissolves in excess of Ki to give us HgI4 2 negative. Okay students, so if we talk about this complex HgI4 2 negative, so Hg is present in a state of +2. It has a D10 configuration. So in a D10 configuration, in case of a tetra coordinated complex, we have a tetrahedral geometry. So students, for question number 26, we have to mark the correct answer as option B, which says that the complex INC has a tetrahedral geometry. For question number 27, as we had seen before, the black PPTD is BiI3. And if you look at question number 28, the orange PPT is due to BiOI. Okay. Let us look at the paragraph given for question number 29, 30 and 31, students. It talks about the synergic bonding in the metal carbonyls. Okay. So for question number 29, it says carbon monoxides form bond with many transition metals. 4 possibilities of metal carbonyl bonding are given below. Select the most favorable type of bonding. So students, if we talk about the bonding in MCO, so we have a metal. So the CO, it forms a sigma bond with the metal. Okay, and the synergic bonding is due to the back donation of the lone pairs of electrons from the metal to the antibonding orbitals of CO, students. So back bonding electrons or the back bonded electrons are donated into the pi star of the CO molecule. So this is a pi bond and this is a sigma bond. So if we look at the options given to us, so in the first option it says that the sigma bond is formed due to the donation of electrons from carbon to metal. This is correct, students. But if you look at the pi bond is incorrectly represented. the pi bond is from the pi orbital of the metal to the pi star of the CO. So it is incorrectly represented. If you look at the second option now, the sigma bond is incorrectly represented as well as the pi bond. If you look at the third option now, in the third option the sigma bond is correctly represented, but the pi bond is incorrectly represented. The direction of the pi bond will be from the metal to the pi star of the CO. So if you look at the D option, it is correctly represented. The sigma bond is from C to the metal, whereas the pi bond is from the pi molecular orbital of the metal to the pi star molecular orbital of CO. So D option is correct, students. Let us look at the next question now. Question number 30. Which amongst the following metal carbonyls does not use d orbital in hybridization and has diamagnetic property? Okay. So if you look at the options which are given to us, we have NiCO4. So NiCO4, nickel has a 0 configuration, so it is S2D8. In presence of carbonyl, which is a strong field ligand, it is going to have D10 configuration, and so the complex will be sp3 and diamagnetic. Okay, so the first option is correct, students. NiCO4 is sp3 hybridized. It does not use the orbital in hybridization and it has a diamagnetic nature. If we talk about the B option now, FeCO5, metal is present in a state of 0 in this case as well. So Fe is S2D6. Carbonyl will cause pairing, so it is going to have D8 configuration and it is going to have dsp3 hybridization. So it is diamagnetic, but it involves d orbital, so this cannot be an answer. If you look at VCO6 negative, students, in VCO6 vanadium is present in a state of 0, so it has S2D3 configuration. So it has vacant orbitals, it is going to have D2sp3 hybridization as well. So this is not an option. And if you look at the last one, chromium is present in a state of 0 again, S1D5. So again it is going to have D6 configuration and it will be D2sp3 hybridized. The CO ligand will cause pairing. Okay. So for question number 30, the correct answer to be marked is option A. Let us look at question number 31 now, students. Arrange the following metal carbonyls in the decreasing order of CO bond length. Students, if we talk about this CO bond length, it depends upon the extent of back bonding. So as the extent of back bonding from metal increases, so as the extent of back bonding from metal increases, it implies that the metal carbon bond order increases, which further implies that the carbon oxygen bond order it decreases, which further implies that the carbon oxygen bond length increases. Okay, so we need that metal which has the greatest extent of back donation for the CO bond length to have the maximum value. Okay, so if we talk about these complexes, students, we have Ni0, Fe0 and we have Cr0. So Ni0 has D10 configuration, Fe0 has D8 configuration and Cr0 has D6 configuration in presence of CO, which is the strongest ligand. Okay, so students, if we now talk about the number of lone pairs available, we have 5 electron pairs or 5 lone pairs in nickel, we have 4 lone pairs in Fe and we have 3 lone pairs in Cr. So this 5 lone pairs can be donated into 4 carbonyl groups. So per carbonyl the effect will be 5 by 4. If we talk about the second one, we have 4 lone pairs which have to be back donated into 5 carbonyl groups. So per carbonyl the extent will be 4 by 5. And if we talk about the last one, we have 3 lone pairs which have to be donated into 6 carbonyl groups. So the extent of back donation per carbonyl group is going to be equal to 3 by 6. So if we talk about the extent of back donation, we can clearly see that the extent of back donation will be maximum in NiCO4, followed by FeCO5, followed by CrCO6. So if you talk about the extent of back donation, it is going to follow the order 1 more than 2 more than 3. So the bond length between C and O is also going to follow the same order. So extent of back donation. So the extent of back donation, it will follow the same order as the bond length of CO as we had seen before. So the correct order is going to be 1 more than 2 more than 3. So for this question, students, we have to mark the correct answer as option B.